All right, folks, today we're going to be working on 10.7, day 1, which is on circles on a graph. Coordinate plane, that word on the top is just another word for a graph. And we're specifically just going to focus on today for day 1, this first learning target, where we could just write and graph equations of circles. So everything in this box here is important for setting up how we're going to write these equations. We're going to use x and y to represent any point that's on the circle, and you can see that we say again on the circle on the outside. So there's our point xy on the outside of our circle. And our center is at the origin. The origin is the point 0, 0. We think of that as kind of the dead center of our graph. And then a radius r, we know what that means. We get our equation of our circle, we derive it from our Pythagorean theorem, which is x squared plus y squared is equal to r squared, something we've seen before in class. Where if we zoom in on the picture here, the length along our x-axis is x, the length along our y-axis is y, and then our radius we could see from getting from this origin to a point on the outside, or the center of our circle to the point on our outside. So this is the equation of a circle with the center at the origin specifically. Right, the center is at 0, 0 with a radius of r. Let's say our circle is off center and we don't have our center at the origin. We're still going to use xy to represent any point on the circle, but now our center is going to be, we're going to represent it as h, k, where that is the center of our circle, and h is our x value, and k is our y value. Someone probably smarter than me knows why we use h and k. I do not, so don't ask me. And again, radius r. So now by the Pythagorean theorem, we have to have this x minus h and this x and this y minus k, because our circle is offset now. We could see how our diagram changes. To get the distance from here to here, we take our initial x value minus how much we offset it by, so h. So again, this right here is our center of our circle, h, k. So if we're looking to write an equation of a circle, we're going to be plugging in numbers for h and k and r. X and y are always just going to be there. They're kind of placeholders. We don't touch those at all. And then this is a standard form of equation with a circle at h, k. Two big differences, and we're going to use both of them. So these three examples just ask us to write the standard form of each circle, and it kind of gives us conditions. So we'll start with the first one, where we have a center of 0, 0 and a radius of 3. So since our center is 0, 0, we could use that first kind of standard form I gave you, or we could write this out. We could say, well, it's x minus h squared plus y minus k squared, and that's equal to our radius squared. But like I said, we're only plugging in things for h and for k, and then our center is 0, 0. This is our h, and that's our k. So we could plug in zeros for h and k. We would write x minus 0 squared plus y minus 0 squared is equal to our radius is 3, so we can plug in 3 squared. We go through and simplify. X minus 0 is just x, so we can write this as x squared. Y minus 0 is y, so we can write this as y squared. And then 3 squared is 9. So this is an equation of a circle with a center of 0 and a radius of 3. Example B, now we have a center of 0, -9 and a radius of 4. So I'm going to take the same approach. I'm going to write out my equation of a circle again and plug in my points. So again, my 0 is my h value, my -9 is my k value. So I'd plug in x minus 0 squared plus y minus, and my k is -9, so I can make sure I plug in -9. And then my r squared, that would be 4 squared. So simplifying this out, x minus 0 is x, so we have x squared plus y minus -9. This minusing a negative turns this into a chunky plus. So we would write y plus 9 squared, and 4 squared is 16. So there is an equation of a circle with radius of 4 centered at the point 0, -9. Our last example, example C, our center is now at -2, 5, and we have a radius of 7. So we're taking the same approach here where we're going to plug in what we know and then simplify. This is x minus -2 squared plus y minus 5 squared equals 7 squared. Again, subtracting a negative turns into a chunky plus. So we have x plus 2 squared plus, we have no simplifying in our other parentheses, we can just write it as y minus 5 squared. 7 squared is 49. So this equation of a circle with the radius of 7 centered at -2, 5. So that's one kind of thing you'll have to do on your homework, write out equations of circles using your formulas, your radiuses, and your centers. Now we're going to kind of do it the opposite direction where we have a point on our circle and we have our center and we have to write the standard form. Well, if we know the center, we know what our h and our k is. It's -1 and 3. But we don't know what our radius is. That's our question mark. We know we could find the radius by taking the length of our line from the center of our circle to any point along the outside. And we happen to be given a point, so we're going to use that. And to find the distance between 2 points, we can use our distance formula. So this is our radius. So how I like to write this, our radius, this is equal to our distance between our 2 points, which our distance formula, going back to the first unit of the year, it would be x2 minus x1 squared plus y2 minus y1 squared. Where we can use our 2 points as our x1s and x1s, y1s, x2s, y2s. It doesn't matter which one you pick. Let's say this one's x1 and y1. This one is x2 and y2. So we plug in what we know now. We say our radius or our distance is equal to the square root of x2 is -5, so -5 minus -1 squared, plus our y2 term, which is 6, and then our y1 term is 3, so we have 6 minus 3 squared. So our radius is equal to, if we simplify, this again turns into a chunky plus. So you have -5 plus 1, it's -4. So -4 squared plus 6 minus 3, that's 3. So we have 3 squared. We can go through and continue to simplify. This would be equal to -4 squared is 16. 3 squared is 9. So 16 plus 9 is 25. So if r is equal to the square root of 25. 25 is a perfect square, so we get out r is equal to 5. All right, what you don't want to do is just count the boxes. If you try to count the boxes, it's not going to be exact. will give you exactly 5 boxes from one point to the other, so you got to make sure you're using your distance formula. That should be all you need to get started on 10.7 day 1 practice assignment. That will be on Big Ideas. The answer key is posted, and good luck.